Email rate control. The spam emails are quite annoying. The server under the spam email attack would be brought down if the arrival rate of the spam emails were over the capacity that the server can handle. At our border control interface border rule add rule, we can set the rate limit, connections per second, for incoming SMTP traffic before we really process the content. But what is the proper value to be set in the firewall on rate limit control? The answer may vary when the length of spam mails or the number of virus signatures is changed. We suggest using the math model establishing in queuing theory to do estimate after you collect enough statistics. Let the requests arriving at the system is a Poisson process with rate mu, and the time spent on handling those requests is IID, independent identical distribution, with exponential distribution function, and that also can be formulated as a Poisson process with processing rate lambda. In stochastic process theory, it turns out to be a birth and death problem. During the steady state, the expected queue length n equals mu slash lambda mu, where lambda mu in the scenario on the email server protection, if the processing rate of emails by the email server is lambda emails per minute, and the queue length is given as n to protect the server. Thus, from the formula above, we can know how to set the rate limit on the firewall. To be specific, given processing rate of emails, 12 emails slash min the average queue length expected, 20 then we have 20 equals mu slash 12, mu, so, mu equals 11.43, emails slash min, thus, we should set the peak rate limit on SMTP connection to 11 connections per minute to protect the email server from being bombarded by spam emails. What is the reason that this topic is brought up here? It is something to do with email server performance. Assume that you found out it took 5 seconds in average to process an email after scanning 1.7 million virus signatures and content analysis to decide if it is a spam. Unfortunately, you have spam emails arriving at the rate larger than the processing rate mentioned above, and those spam emails are coming day and night for quite a long time. What would happen? Intuitively, everybody would know that it would have a lot of emails staying in queue to be processed so that the email server is always sluggish to any request. Review the model we mentioned above. We have n equals mu slash lambda mu. It implies when the processing rate is almost equal to arrival rate, the queue length is going to infinity. So, if somebody claims to you that an email server can process 1 million emails a day, you should ask about how the test scenario is performed. If that scenario does not take data arrival rate into account, you should not expect that the email server could handle 1 million emails a day. What can we do if we have quite large of spam emails coming in so that the system cannot handle? If virus scan and content analysis take too much time to process, the best approach is looking for other approach to eliminate spam emails faster. And before that right approach is complete, regulating the traffic into email server can be done by using rate control in the firewall. But as you can predict, regulating the peak arrival rate for spam emails also hinders the arrival of good emails. It only keeps the server alive, but the other party might try quite a long time to have their emails delivered to your email server. It should combine with other methods to tackle the problem. Email server defense. There are several straightforward ways to avoid overloading the email server under heavy volume of spam emails. For example, if there is no such recipient in this email server, that email could be rejected right away without going through virus scan or content analysis. However, it might open the opportunity for the spammers to use a quite long list of usernames, the so-called dictionary attack, to check the existence of valid users of the system. So, sometimes, people choose to swallow them and discard them silently without giving any clues to the spammers if the system performance is allowed. A lot of spam emails come from hosts without fully qualified domain names, or they come from the IP addresses that do not have any records in reverse DNS lookup. Those can be used to screen spam emails. But it should be careful that this would also kill good emails. For example, a lot of people do not put their IP addresses into reverse DNS records because of privacy reasons to avoid people collecting domain names by using IP addresses directly. And some people just put their email host name into DNS server with a record without MX record by hoping that the email server would not be identified as a target by spammers, or some people's configuration is using different SMTP hosts to receive emails or send emails, or it has to go via mail relay. For those exceptions, you have to remedy them by using while list. For those places you know that your users would not receive emails from, you might as well to put them into blacklist when the email server is under heavy volume of spam emails. In the following, we will explain more on that to see how it can be done via the provided functionalities. Setting for rate limit control. The following is the screen snapshot of the firewall rule setting. It can be navigated via border rule add rule. So, when we try to regulate the connection rate of incoming emails, it is sufficient to put restriction on SMTP traffic. And we know SMTP is with TCP port 25. 1. The rule associating TCP port 25, we place rate limit. In the field rate limit, average means the system will compare the rate of the current traffic with the average value since the last reboot time of the machine. If it is over that limit, it blocks the connect. Burst means, on any measured unit of time interval, it should be not over this limit. SMTP connection screening. While the volume of spam emails is over the processing power of virus scan and content filtering, we might just block the SMTP connection before those emails are processed. Navigating via Email Defense Dynamic Screen, you will find out there are several checkboxes over there. As indicated, those actions might also block the emails you would like to receive as well. To remedy that, you need to place those hosts or their IP addresses into SMTP restriction list and tag them as OK. For those emails sending out from the hosts you obviously do not want to receive, just tag them as discard. That SMTP restriction list will be used when the checkbox associated with SMTP restriction list is checked. But how can we collect the list about where to block? It needs some analysis. And remember, it is not necessary to block all the spam emails in this way, we only reduce the volume to the level that virus scan and content filtering can catch up. Check SMTP connection via reverse DNS lookup. If you have a chance to take a look at the statistics about the IP addresses using that spam emails, you might be surprised that they come from thousands of different IP addresses. IP spoofing can achieve this effect by faking source IP address in the IP header. Nowadays, most network gateways should have ingress filtering by rejecting the packets with source IP addresses within its network but coming from outside, or egress filtering to discard the packets by rejecting those packets with outside network IP address in source IP address field but originating from inside. If that is the case, we might assume that those spam emails come from the open proxies or hosts controlled by the spammers by hopping IP addresses. A lot of IP addresses are used by spammers only once. Thus, blocking specific IP address might not be helpful at all. Thus, we might just try to do reverse DNS lookup on those collected IP addresses to check the domain names associating those IP addresses. The following diagram from Email Defense Domain Block shows the implementation of this scheme. It has level 0, level 1, and level 2 to show different tier of the domain names. By digesting the information, it might easily to get those spam mails come from. Under some circumstances, people just use country code to block spam emails to alleviate the processing load. Anyway, you can just add those suspicious domains into restriction list. The first column in the list box provides the number of connection times from that specific domain from top to down. If 99% of emails are classified as spam and they are coming from some domains, we can just put those domains into list to discard those emails without further processing. However, if you have chance to use level 2 analysis, a lot of IP addresses could not be resolved via reverse DNS lookup, they are tagged as unknown. If reverse DNS lookup is used as criteria to reject emails, all of those emails from unknown will be rejected. But as we mentioned previously, it could also block the legitimate email servers. Thus, we might need more detailed analysis from unknown IP addresses not resolved via reverse DNS. The functionality here at Email Defense Network Block is to provide analysis on those IP addresses that cannot be resolved from reverse DNS lookup. The first column indicates the number of connections from that IP address or network, it is also listed from the most to the fewest. The second column is the accumulation from top one to the current one. Thus, at the last row, you should see the total number of connections at the second column. Please notice, if you select or type 208.168 to SMTP restriction list, it will match all the IP addresses from 208.168. An SMTP connection includes all of the attempts on trying to connect to the email servers for sending and receiving emails. For the people sending out emails, it is also SMTP connection. So, you will see some private IP addresses shown in the list. Sometimes, it is not a healthy signal if you see a specific IP address from your local network to send out a lot of emails. It could imply that that machine is with virus. The SMTP restriction list will not block the SMTP connection when it uses user account and password for verification. To do that, it should be done on the firewall blacklist via border connection update blocked host. If processing spam emails with virus scan and spam tagging by analyzing the content does not occupy too much CPU time on the machine, it is not necessary to use those measures. However, under some circumstances, those measures can be quite useful to alleviate the system load. Email authentication overview. The term email authentication we use here is to refer all of the methods for checking the validity of email servers. It is mainly referring to authenticate sender's domain name via DNS. It is different from email content filtering or author's digital signatures. Here we only give a brief introduction of those email authentication schemes so that people can establish enough knowledge to use those features provided on the email solutions. However, for more detailed information, please check their respective specification documentation. The schemes SPF, Sender Policy Framework, Sender ID, Domain Keys, and DKIM, Domain Keys Identified Mail, are designed to verify sender's domain name associated with emails. The simplest method for email authentication scheme is reverse DNS lookup plus forward DNS lookup to check if the IP addresses of incoming emails are matched with those domain names. However, simple reverse DNS lookup and forward DNS lookup are not flexible enough. they are not designed for email authentication originally. Why those verification schemes are proposed can date back to the protocol design of SMTP, Simple Mail Transfer Protocol, and the prevailing email forgery by faking a domain name to send out emails. Thus, email authentication schemes are come up to resolve those issues.